My name is Panickos Neophytou. I'm one of the co-founders at NetBeez. And today I will be talking about how you can get active network performance metrics from NetBeez using the API. So in the past, I have talked about the different ways you can use the APIs to build custom dashboards, integrations, as well as build analytics pipelines. But today, in today's sessions, I'll try to go deeper into specific API endpoints and provide you with a mapping between components and visualizations you see on the dashboard and actual endpoints and the kind of data that they return for you to better understand the power of getting these performance metrics out of the API. And at the end, I will bring it all together with a real example from one of our customers who have built an external dashboard for their support engineers to use in order for them to easily discover worst performance in their networks and be proactive about finding the area of the root cause and maybe even notifying their users about problems they are having before their users complain about them. So just to give you a high-level idea of how these network performance metrics are gathered and made available, I'll go through this architecture diagram. So as you can see, different endpoints are deployed across your network. Could be on-prem, on the cloud, as well as in users' homes through remote worker agents. And these are continuously measuring end-to-end performance and from the edge of the network towards all the necessary network services. Then those measurements are gathered onto the NetBeez server and are finally made available to be pulled through our API to either third-party applications, network automation tools that need real-time data to make informed decisions about configuration changes, and maybe even after these automation tools apply configuration changes, they can validate those changes using data from NetBeez. And then finally, you can also build custom dashboards that can provide the status of your users to help the support engineers or even the end users themselves, if that's how you want to operate, who can perform some self-help troubleshooting using this high-level data and avoid opening tickets. So just to go through the history of our API, we started on with what we call version 0. That was our initial internal API for the dashboard. It was not for public use, and this will be phased out by the end of 2022. Then we released version 1, which was the original public API we released. It was read-only with documentation available on Swagger, and this is also going to be phased by the end of 2022 once we transition everything to our JSON-API, which is intended for public and internal use. So the dashboard is also using this. It provides read and write support. So for example, it would give you the ability to create new targets as well as run ad hoc tests. And these are important things for automating your configuration of NetBeez. And the documentation is available through Postman at api.netbeez.net. And the very important thing about this new API is that it follows the JSON API standards. So it's easier to digest, it's easier to integrate with, and there are many libraries out there able to parse the JSON API format. So what are these active network performance data we're gathering? So it includes agent and endpoints information, like the operating system version and other information that we'll go through later on. Real-time test measurements such as ping, DNS, HTTP, traceroute, and path analysis, which are also all of these made available through the API. Scheduled test results for iPerf, network speed, and VoIP. Wi-Fi metrics regarding connection timing, signal strength, and so on, as well as alerts and incidents that have been triggered. And this data is provided at different levels of granularity, from raw measurements to different levels of averages over different periods of times or different window sizes. So let's jump into this specific example. So on the right-hand side, you can see how we visualize the data on the dashboard. So you can get the agent status, operating system version, the timestamp that the agent has been active since, and the test status aggregates. You can have information about the network interfaces and on the internet connection side, external IP, and the ISP name and the autonomous system number of the ISP. And you can access this information using our generic index agents API, which will basically return all this information in a JSON format that it can be programmatically parsed. So you can see here even the access point that the agent is connected to, the network interface information, IPv6 addresses, external IPs, when it was last connected, and all kind of information here. Next, another information on the agent side available from the dashboard is the availability of the agent as well as the performance metrics. And in order to get those, you can get the availability of the agent based on a from and to timestamp from the NB Agent Statistics API, which will give you interval, the uptime, and basically based on the window size you chose. So in this case, it's giving you the uptime of this agent over the last 24 hours. And in terms of the CPU of the performance metrics, you can get those from our new JSON API endpoint, which will give you a series of objects based on your from and to timestamps on CPU utilization, memory utilization, and the disk utilization as a time series.
For the do you provide additional information for the CPU utilization and the RAM utilization as far as what processes are using the allocated to each of those, or is it just the
at the moment we just give the high level utilization of the CPU, memory, and disk that will basically give you an idea of where the root cause is. Now, if you want to dig deeper, you would have to work with your user to get that information. Now, of course, if we get enough interest on this feature, we can definitely add more measurements here to include with the same information. This covers all the agent part of the API. So next we go to the test results and statistics. So we have, as I said before, the 4 or 5 type of tests. On the dashboard, they are visualized in a timeline. Here we have the raw data, and you can access latency, jitter, and MOS, for example, for a ping test. And that information is available through the results API, where you can specify the test ID of the test you're interested in, and the from and to timestamps. You receive back a series of data, a time series of data where you have the value, the timestamp, and so on. Now, for the statistics, since the data is available also in different average granularity, you could basically define the window size in different granularities and the range of timestamps you're interested in, and also the metric type. In this case, we have mean. Gives you a time series of the mean results, and you can also from here you can get the jitter as well as MOS estimates of those results. Next, we have the aggregate data on a per target basis. So targets are basically containers of tests run by the agents. So we can aggregate these test results over multiple agents, and you can get average information over a time period as a time series from the API. And this is how it's basically visualized on the dashboard. The top line is the average response time, and the bottom line is the timeline of alerts triggered. And in order to get that information for the average performance, you go to the NB test statistics endpoint as before, but in this case, you just specify the test template ID, which basically represents, in this case, the HTTP test, and that will provide you again with a time series of values on the specific test template ID, and the average over all of the agents that are performing this test. Then for the alerts, there is an open alerts at intervals API where you specify from and to, and this will return a time series of the counts for each of the severity of the alert that is being triggered. So, and that's how we build this graph on the dashboard. Next, we have an agent alert aggregates API, which gives you a list of all the agents sorted by the performance and the critical alerts that have been triggered. And this is how we build this graph on the bus tab of the dashboard. So on the x-axis, you have the critical alerts, and on the y-axis, you have the warning alerts, performance alerts. And this can be accessed by this JSON API. We have available group alert counts, and that will return for each agent for the time period you specify how many alerts of each severity have been triggered by that agent. Moving on, scheduled test API, we have this visualization on the dashboard where on the top part, we show the averages on a per run basis. And then when you click on a specific run, it breaks down the results into this visualization graph where you can filter and view individual agents. So to get the top part, which is the averages, you can go to the scheduled test templates, you specify the template ID, the results, and the statistics endpoint, as well as the from and to timestamps, and you get back a series of data with their timestamp with the 3 key values of the test: latency, upload, and download speed. And then when you want to get for specific timestamp and specific agents, you can get those by the API. You can get those using the results API, which will give you for individual agents, again, each of these 3 key values. So next, we have the Wi-Fi metrics. I'm not going to go through all the API endpoints, but you get the idea where we have for each and every one of these metrics, you can get the results back from our API in order to identify users within low coverage areas, or if they're working from home, if they're having any Wi-Fi issues. So this data is also available through the API, as well as the Wi-Fi connection timing. This is mostly related to the on-prem Wi-Fi agents, where they are continuously testing your enterprise network. You can get the Wi-Fi performance, averages on a per access point or per SSID network, and then on a per agent basis, you can get for each connection attempt that agent performed, you can see how much association, authentication, DHCP, and the network test times 2. So putting it all together, one of our customers wanted to provide a high-level dashboard where their help desk can be proactive into finding out which users were having performance issue, either with their ISP network, having high latency, or if their jitter audio quality MOS score was low, having extended packet loss, or if their gateway is not performing well. They wanted to get all that information in one simple dashboard and make this information available to them. So in order to build this dashboard, they used various APIs. So for example, here the agent API can give you the different users that are connected to the dashboard. Then using that list of users, you can get the tests that those agents are running, and then get the statistics for each of the agents, and then apply these thresholds to those metrics in order to color the boxes red or green. For the download and upload speed and latency, they use the scheduled test results API. And then finally, for the Wi-Fi MCS score, they use the Wi-Fi metrics API. So they were able to bring all this data together here and provide this dashboard to their help desk support to be able to be proactive and find things out before their users complain. This way, they were able to reduce ticket escalation by a huge factor. So all this information that I went through is available through documentation and examples. We have a few examples on our GitHub page. If you go to /netbeez/NB-API examples, we have that. We have some code there that you can see. And on Postman at api.netbeez.net, we have all the documentation of all these APIs that I mentioned, and very well documented information about what are the attributes used for each of the endpoints and what are the return values.
So obviously, just the NetBeez platform, when you're looking at this from the user point of view, and you're helping the help desk, just anybody in that support organization. Mm-hmm. But another place where we see things like this is within SD-WAN, making determinations on your path based on, mm-hmm. well, hey, this application is working better down path 1 versus path 2. Have you seen anyone try to sort of merge your program into an SD-WAN platform to help that platform, to like sort of inform that platform on the best path, or just right. any kind of mergence into that field?
Yeah, so as I mentioned in the beginning, our intention is to make this information available to all these tools and be able to inform them about the status of their network and all these kind of things to help them make decisions. I'm not aware of any specific customer that has done this at the moment, but as you understand with having this presentation, we're trying to push for that kind of integration for sure.
Okay.
And yeah, we're definitely open for feedback, and we try to make these APIs as useful as possible to everyone to integrate with these kind of tools.
So then you're sort of like your vision of that, and the mm-hmm. reason that you're building out the API is to help enable.
Yep.
Okay.
Exactly.